Moving on from arithmetic sequences, we're now going to talk about arithmetic series, so the sum of the terms in an arithmetic sequence. There is this general formula which states that the sum of n terms in any sequence is equal to the number of terms divided by 2 times the first term plus the last term. And I feel like this equation requires a little bit of an explanation. So my explanation is in the form of a story. There is the story that goes, and maybe I've made it up, but there was a young student, a budding mathematician named Gauss. And his punishment in class for being a bit of a brat was to find the sum of the first 100 natural numbers. So his teacher wanted him to go 1 plus 2 plus 3 plus all the way up to plus 98 plus 99 plus 100. And as the legend goes, this was supposed to take Gauss like forever, but he did it in a matter of seconds. And what he recognized is that because this is an arithmetic series, that if you write the same sequence of numbers forwards and backwards, magic happens. So if I go 100, 99, 98, plus 3, plus 2, plus 1, you'll notice that if you add the corresponding number from each forwards and backwards of the series, you get the same number. 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101, right? All the way through to the end, you're still getting 101s. So he said, that's interesting. So if I'm trying to find the sum of these terms, if I take the first term, which is 1, and I add the last term, which is 100, which in a sense is adding the second term and the second last term, the third term and the third last term, I end up with this constant sum, this 101. So if I just did that, 1 plus 100, I get 101. Well, how many 101s do I get here? Well, there's 1, 2, 3, 4, all the way up to 100. So there's 100 terms. So there's 100 101s. But we got 101 by adding the sequences together twice. In other words, first and last and second, and so on and so forth. So really this sequence ran twice. So what we would have to do is then divide by 2. So if I then say, if I want to find the sum of the first 100 natural terms, I plug in n is 100. I plug in my first term is 1, my last term is 100, and I do it, I get 50 times 101. I get 5,050. And you'd get the same thing as if you sat there and literally just went 1 plus 2 plus 3 plus 4, but it'd be a waste of your time now. So because of Gauss, we have an equation now to find the sum of any arithmetic series. So for example, if I wanted you to find the sum of the first 15 terms of this arithmetic sequence, I no longer have to write out all 15 terms and add them together. Instead, I can use the summation equation. So n divided by 2, first term, plus the last term. So in this case, my last term is going to be my 15th term. So my number of terms is 15. I'm going to add the first term, which is 4, to that 15th term. Now, the way that we have this formula set up, they don't give you the 15th term. I've seen this formula done sometimes where they take your general arithmetic sequence equation and put it in here so that you can always just use one general formula. But for us, if they don't give you the 15th term, you have to find it. And to find the 15th term, you use your other arithmetic sequence equation. So that would go nth term is equal to the first term plus n minus 1 times d. So in this case, the first term is 4. The number of terms is the 15th term we're finding, so is 15. And my common difference is 7 minus 4, which is 3. Plugging this in, I've got 4 plus 14 times 3, which is 42. And that gives me 46 is my 15th term. So now you can take that 46 and you can plug it in for the 15th term. Boom, boom. And then we plug it in. So 15 divided by 2 times 50, which gives us 375. So the sum of the first 15 terms in this sequence is 375. And now that you've learned how to use the formula, the only extension is to apply it to the summation equation, so to something that's in summation notation. To use it, the first thing you want to make sure is that this is an arithmetic sequence. So to do that, we're going to plug in values of k and see what the terms are. So if we plug in k as 1, we've got 4 times 1. If we plug in k as 2, plus 5, k is 2, so this is the first term. The second term would be 4 times 2 plus 5. The third term would be 4 times 3 plus 5. And let's just check. So the first term would be 4 plus 5 is 9. The second term is 8 plus 5 is 13. And the third term is 4 times 3, which is 12, plus 5, which is 17. So we can see that this has a common difference of 4 between each of these sets of terms, which makes this arithmetic, which means we're allowed to use the equation Sn is equal to n divided by 2 times a1 plus an. All right, so first thing we want to figure out is how many terms are we adding together? Well, you're going from where k is 1 up to k is 130. So to figure out the number of terms, this one's pretty simple, it's 130. But to use these values, you go 130 minus 1 plus 1. So you get 130 terms. The reason why you have to add one is because think about when we did the third term to the, 16th term, right? You added the common difference 13 times, but there's actually still that first term, right? There was that third term. So you have to add one to say, okay, well, that's how many times we added the common difference was 129 times, but there was a first term to start with, which was 130. So we're finding the sum of the first 130 terms in this sequence. 130 divided by 2, where the first term we discovered was 9. Now we want to find the nth term. So we want to plug in k is 130. So to find that 130th term, we're going to plug in k is 130, and we end up with 4 times 130, 4 times 130, plus 5, which gives me 525. All right, so that's what we're going to plug in for the nth term. And of course, because we knew the sequence 9, 13, and A17, if you'd use this formula, you'd get the same thing, right? So we could come up with a new general equation for this guy. This is just the simplified form of it. You could plug it in here, or you can plug it into the equation that they gave you. Then we can just plug this in. We get 130 divided by 2 times bracket 9 plus 525, which gives us 34,710. All right, pause the video and give this one a go. So hopefully you did pause it. So for this one, you're plugging in k is 5 for the first term. So you would plug in k is 6 for the second term, and so on. I know this one's going to be an arithmetic sequence, so I only need the first two terms. So the first term is 40, the second term is 48, and so on. Okay, so that makes my common difference 8. But we need to find the last term. So the last term is going to be where k is 20. So up to where k is 20. So we're going up to 160. All right, so my equation is Sn, sum of n terms is equal to n divided by 2 times the first term plus the last term. Number of terms. Okay, so this time we're going from where k is 5 up to k is 20. So the number of terms would be 20 minus 5, but then you add that first term back on. So the number of terms is 16 terms. So I'm going to plug in n is 16. And you're finding the sum of the first 16 terms, where the first term is 40 and the last term is 160. Then we plug this into our calculator. 16 divided by 2 times 200, and you get 1,600. All right, go and master arithmetic series, and then we're going to come back and do some word problems where you don't know if you're talking about a sequence or a series.